All right, hello everybody. So today we are going to start into our chapter 5, section 4 studies. And this is actually only going to be a one video section. And this one contains some information about how to solve or graph what are called compound inequalities. And what compound inequalities are is they are inequality statements that contain the word and or the word or. So you can see and or. And those are actually the two types. And what you see here is what an and inequality looks like. And what you see here is an or inequality. The easiest way to tell them apart is that or inequalities will literally have the word or in them. And inequalities do not, but or inequalities do. The second thing that I want you to notice about this is when you have an and inequality, what you end up with is one solid bar that looks like this with dots on either side of the bar. Now those dots can be open or closed, which we'll talk about what they are and why they are here in a second. But that's what an and looks like. An or inequality is going to look like this, where you have dots and then you have the outside parts shaded and the inside is not shaded. You can see that part right there does not have any shading. So what you see here, this one, that's called an and then this is an or. And those graphs, the dots on where the dots show up on the numbers is going to change, but the general shape of the graph of those will not change. This is what an and looks like. This is what an or looks like. So, vocabulary compound inequalities containing and or. So, ands overlap sections. And so, what it means is you have to meet one requirement and the other requirement. So, as an example, they're showing you if I want my x to be greater than or equal to 3, you can see that there's a solid dot on 3 because it's or equal to. And then we are graphing to all the numbers bigger than 3. So we're shading to the right of 3. And you can see that right there. Notice the shading goes in the same direction in this case as the sign is pointing. Okay. Now, if you look at this next one, it says x is less than 7. So what we do here is we put a dot on 7. Notice the dot is open in this case, though, because it's a strict inequality. There is no equals. When it's equal, like you see here, greater than or equal to, we get a solid dot. When it's just less than or greater than, no equal sign, you get an open dot. So that's the first thing that you need to understand. The next thing that I want you to see with this, though, is how the shading was done. So if you look at the shading, this says x is less than 7. So we start on 7 and we shade to the left because we're looking for less than. Now, what an and inequality does is an and inequality combines those two graphs into one graph. And so if you look at the way the shading would overlap, you can see there's some shading that starts right here, and the top one goes this way. This one starts here and goes this way. And so if I took this graph and superseded it, or superimposed it, I should say, onto the other graph, what you're going to see is you're going to see a combined and graph. And I'm going to see if I can actually do this. I'm going to graph right here and move this over. Then I'm going to go over here to this green and I'm going to go like this and move this over. Now let's see if I can get fancy here. If I cut this graph out right here, and I put this graph over top of this graph like this, you can see they combine over top of each other. The part that we're interested in is we're interested from here to here and in between where that shading is overlapped. That's from here to here. All the shading, you can see the orange and the green are right there. And so then if you look at this graph that we have down here at the bottom, you can see that we are only shaded in between the two numbers. Okay, and that's what an and graph is. It's a combination of both of the graphs where both of the graphs overlap each other. So as I move in here, it says solve and graph an intersection. Okay, so to solve this, it's quite simple. We're going to add 3 to both sides, and we get y is greater than -8. Over here, I'm going to add 3 to both sides, and I get y is less than or equal to -5. Now, we're going to graph those together. And the way that we're going to graph those is I'm going to draw a line like this. I'm going to start, let's start at -10, then -9, -8, -7, -6, -5, -4, and -3. And so what I want to do is I want to graph both of these together. Now I'm going to graph this first one. I'm going to graph this with red. And this second one, I'm going to graph it. We'll go with like a green color there. Okay. So let's graph. The first one is y is greater than -8. So I'm going to put an open dot because it is greater than, not equal to. And then we've got to shade the numbers that are bigger than -8. And those numbers are over here. Okay. Now the second one you're going to see is we are going to graph y is less than or equal to -5. So that's a solid dot because it's or equal to. And then we want the numbers less than -5. So I'm going to graph over here. Now, the important thing to see is where this shading is actually overlapping. It's overlapping right in here. And that would be the and graph, is the overlapping part. Okay, let's try another one. It says solve and graph an intersection. Now, this one's a little bit different than the others because this one has two different inequalities. If you notice right there, there's a less than or equal to, and then there's also a less than. So both of those inequalities are actually going to get a line, just like this. Okay, so the first thing I'm going to do is draw my line. Once I have my lines drawn, I'm going to identify where the variable is. In this case, there's an x. Okay, so I need to get that x by itself. And in order to get that x by itself, I need to get rid of this -3. So in order to get rid of that -3, I'm going to add 3 here. I'm going to add 3 here. And I'm going to add 3 here. Now notice I'm adding it in all 3 places. And the reason why is there are 2 inequalities. Therefore, we have to add the 3 in all 3 sections. Now this 3 cancels. Now these two numbers, -2 plus 3 is +1, and 4 plus 3 is 7. Notice we still have this x in the middle. The last thing to do is to drop our signs down. And you can see this says 1 is less than or equal to x, but then x is less than 7. So to graph this, we're going to draw a straight line. I'm going to start with, we'll go with 0, 1, 2, 3, 4, 5, 6, 7, 8. We'll go out to 8. So I got my number line drawn. Now I need to go ahead and put a dot where each of these say. So looking at this part, it says that the number 1 is the lower dot. Now notice it is a less than or equal to. So a less than or equal to is a solid dot, and it's got to be a solid dot on 1. And then I'm also going to have to put one on 7. But if you notice right here, there is no equals sign there. It's only a less than. It says x is less than 7. So I'm going to put an open dot on 7. So keep in mind, if you have a less than or a greater than sign, that is an open dot. If you have a less than or equal to or a greater than or equal to, that is going to be a closed dot. Now, the last thing to see is this x is sandwiched in between those two numbers. So to graph this, I'm going to sandwich and shade in between the two numbers where my x is. And so what that's showing is for this inequality, you could pick any number from 1 up to but not including 7, and it will make it true. Now we're going to do one more and. This and graph, we're going to do it the same way. We're going to draw a line right here, get our line straightened up. We're going to draw a line right here. And there again, we're going to identify the variable. The variable in this case is t. And you can see what's happening to t. T is being added to 7. So I'm going to subtract 7 here. But I'm going to subtract 7 from all 3 of the places. The 7's going to cancel. And then I'm going to be left with 6 minus 7, which is negative 1. The sign drops. The variable drops. And then I have 10 minus 7, which is 3. So there again, it says negative 1 is less than or equal to t, and t is less than or equal to 3. So that's telling me that that t is sandwiched in between the two numbers, negative 1 and 3. So I'm going to draw my number line. So there's my number line. I'm going to put my dots on here. So we're going to come back and realize, okay, that the negative 1 has an equal sign with it. So it's going to be a solid dot like that. Okay. The 3, however, does not have an equal sign with it. So the 3 has to be an open dot like that. And then we're going to, since this is an and, it's going to get shaded in between the two dots. And there is your graph for an and. Now moving on, for OR graphs are a lot simpler. OR graphs are simply two different inequalities, and then they get graphed in the same number line. And so let me show you how that works. So you can see this first one. I'm going to draw my line here. Okay. I'm going to draw my line for the second one. But these are two separate problems altogether. So I'm going to draw a squiggly line down there. Now this first one, I'm going to subtract 1 from both sides. And I'm going to have a is less than 3. Now this one, I'm going to add 1 to both sides. And I'm going to get a is greater than or equal to 9. So that was pretty easy. All now that we have to do is to draw our number line and graph both of those that you see. So I'm going to go from, I don't know, let's start with 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10, 9, 8, 7, 6, 5, 4, and 3. So there's my number line. And we just need to graph both of these. The first one says a is less than 3. So that particular one, a is less than 3. I'm going to put an open dot on 3 because it's less than. And then the numbers that are less than 3 are over here. So I shade to that side. This second one right there says a has to be greater than or equal to 9. So greater than or equal to means solid dot on 9, and then shade to where the numbers are bigger than 9, which is over here. And there's your OR graph. So they're basically two separate problems. They're just graphed on the same number line. Okay, couple more to do here. Solve and graph a union. So this one's going to be done the same exact way. I'm going to go ahead and draw a squiggly line between the OR because these are basically two separate problems. We'll draw our straight line here. We'll draw our straight line here. Now, what's happening to the R? The R is being added to 6. We're going to subtract 6 from both sides. And so we're left with R is less than negative 14. Now here, we're going to get rid of that minus 3 by adding 3 to both sides. And so I get R is greater than negative 7. So there's two problems. Now the last thing to do would be to graph them. So there's our line. And we have negative 14, 13, 12, 11, 10, 9, 8, 7, 6. Negative 6, negative 7. So there's our number line. And then we're going to put a dot on negative 14. It's an open dot. We're also going to put a dot on negative 7. That's also an open dot. Now this one says R has to be less than negative 14. So we're going to shade to the left for less than. This one says R has to be greater than negative 7. So we're going to shade to the right of negative 7. And we end up with our OR graph that looks like that. All right, guys, I'm going to skip over these because these are exactly the same as the last ones. And I'm going to go on to where you have to write an inequality. Okay, so here's how you write an inequality. The first thing that you have to do is you have to determine whether it's an and or an or. Okay, so this is very, very easy. This one's an and. This is an or. This is an or. That's an and. Now, how do you know that? Well, if you go up here and look at the graphs of the ORs, you can see that the ORs just have graphs at the end of the number line. Same with this one. That's an OR. But if you go up here to the ANDs, you can see the ANDs are one solid graph in the middle. This is an AND, one solid graph in the middle. So that's the first thing that you want to determine is it an AND or an OR? And the reason why you need to do that is because it's going to change on how you write the inequality. Okay, the ORs are easier. I'll give you an example. This right here, this part right here, says X, and we're just going to use an X. X is less than negative 4. Now, why is it a less than? Well, because it's an open dot. Remember, less than or greater than, use open. Less than or equal to, greater than or equal to, use closed. And then we're going to write or, and then this is going to say X is greater than 8. And it's that easy. Okay, and that's not greater than. It should be greater than or equal to because it's a solid dot. Not sure why it erased both of those, but that's what it should be. Okay, let's go over to this other OR, which is number 9. You can see this one says X is less than negative 6 because it's on negative 6 and it's shaded to the left. And then the other part, or X is greater than negative 1. And that's what this part says. X is greater than negative 1. Now, those are easy. The ands are a little trickier, okay? Somewhat. The ands are always going to be in the same way. You're going to have your bottom number, you're going to have your variable, and then you're going to have your top number, okay? So as you can see, the bottom number here is 5. The variable is always going to be in the middle, and then the top number in this case is 9. The last thing to do is to put in your signs, and the signs here are always going to be less than or equal to. And how do you know the difference? Well, when it's an open dot, it's going to be a less than, and when it's a solid dot, it's a less than or equal to. And so what you end up with then is, we can see there, 5 is less than X, which is less than or equal to 9. Okay, I'm going to do one more for you. Number 10. This one, you can see our bottom number is negative 4. The variable goes in the center. Then the top number goes down. In this case, it's a 5. And then from there, we need to put in less than or equal to, depending on which one it is. So this is an open dot. Open dot is a less than. That's a solid dot. So a solid dot is a less than or equal to. And so you end up with an inequality that is always listed least to greatest. That's very important with and inequalities. And that's why you're always using less than or equal to. So, all right, guys, I appreciate your patience and listening. I know this one was a little bit longer, but as always, if you have any questions, feel free to email me. Have a great day.